Hi everyone, I want to go through and give you a little support on this lab activity, the 5.02 Ionic and Covalent Virtual Compounds Virtual Lab. So the resources you're going to be pulling from for this activity are your 5.02 reading, and then this CK12 reading has a little bit of additional information as well if you need a little more than you can get from your reading. So before I even get started, it's important that you're going through and making sure and doing your whole reading prior to starting this activity, because you're pulling from the knowledge that you gain from this reading in order to do this activity. If you're just trying to do it without having done the reading, you're going to be a little bit lost and you're going to have trouble completing the work. So before you get started, you should make sure you've gone through this 5.02 reading. As always, this is in your modules, and it's going to be under last week, the week of 2:9 to 2:13. So that's where you're going to find this in your modules. So first, I'm looking at the objective so that I know what I'm trying to do in this lab. So it says, in this activity, you will perform a virtual investigation to determine whether two unknown compounds are an ionic or covalent compound. So I'm going to have substance A and I'm going to have substance B, and I'm going to do a few experiments on them to try and determine what their properties are. And then I'm going to use those properties to determine which is ionic and which is covalent. So first, I've got a couple of pre-lab questions. This is where I'm pulling my knowledge from my reading. So first, it asks me to describe how an ionic bond forms between sodium and chloride to make NaCl. So from my reading for that, I'm going to be looking on page 2, where it talks about how ionic bonds are formed. And there's an ionic bond example, and it's actually the one that I asked you about in here. So when I go through and I read this section, that's where I can pull my answer for this question. Next, I am asked, sugar is a covalent compound. How are covalent bonds different from ionic bonds? This is also going to be on page 2 of my reading in here, and I just need a pretty quick answer for that one, not looking for anything like a full paragraph or anything for that. And then this is where I really have to start to think about those properties. It's important that I know what these properties are before reading about the experiment itself, because then I can draw conclusions based on what I see in my two substances. So it says, complete the table describing the properties of ionic and covalent bonds. So to do this, here's where I'm pulling information for these. So on page 2, I'm reading about ionic bonding. And if I go into this second table where I see the periodic table here, I'm going to click on properties of ionic compounds. And I'm going to read about the various properties of ions. So I'm going to actually fill this one out with you. So let's see what we find. So it says most ionic compounds exist as solids at room temperature. In order to melt or boil an ionic compound, the ionic bonds must be broken. Because of the strong attraction between the opposite charges, most ionic bonds are relatively strong. It takes a great deal of energy to break an ionic bond. For this reason, ionic solids have high melting points and boiling points. This strong, attractive nature of ionic bonds is in part related to their ability to dissolve in solution. Those that do may only dissolve to a small extent. For example, when sodium chloride is added to 100 milliliters of water at 0 degrees C, we can expect 35.7 grams of NaCl to dissolve. Many ionic solids will dissolve in water because of the strong attractive forces of water molecules. So you can keep reading there, but I have enough to do this first row now. So it told me that the boiling and melting point are going to be very high for ions because of the very strong bonds. So that's what I'm going to fill in there. And it also said that most ions are going to be completely soluble in water. And then let's see. I have and here's my conductivity here as well. So when solid sodium chloride dissolves in water, it separates into sodium ions and chloride ions that move about freely in solution. The attraction between the Na and Cl ions is in the solid is so strong that only highly polar solvents like water will dissolve NaCl. Recall that ions are charged particles, and freely moving charged particles or ions are able to conduct electricity. So that's my last question here. Conductive when dissolved in H2O. All right, so then for the covalent row, I'm going to be on the next page. And similarly, I'm going to go into this table and I'm going to find properties of covalent compounds. And I'm going to go through this and I'm going to use that to answer the questions on this second row here. So I'll leave that for you guys to do. And then the actual lab is started. So it says, introduction, it's time to bake. Look at that delicious baking pie. Baking is all about the right ingredients. In this virtual lab, you'll have to identify the correct chemical compounds you need to bake the absolute best pie. You look around and find some materials to use. You have a hot plate, a thermometer, a scale, a measuring spoon, water, and beakers. You need to plan an experiment to test the properties of the unknown compounds and determine which one is salt and which one is the sugar. So now I know I've got two compounds that I'm trying to explore. Lab safety, never taste an unknown substance. So that's why we're not just licking these and seeing, oh, this one's sweet, this one's salty. We never want to taste an unknown. And so we're doing an experiment to determine which substance is salt and which is sugar. You plan to dissolve a sample of both compounds in water. How quickly they dissolve can tell you something about the strength of the bonds. Which type of bond is stronger, ionic or covalent? And if the bond is strong, do you expect more or less of the substance to dissolve? Go back through the lesson to review these characteristics of ionic, polar covalent, and nonpolar covalent bonds. The solutions with compound A and compound B should dissolve different amounts of solute because we are assuming that one is ionic and one is covalent. So before we get started, we know that our salt is ionic and our sugar is covalent. So we should say we expect for our salt to behave according to these ionic properties and our sugar to behave according to these properties. So when we go in and we do our hypothesis, we're just filling in the blank for our prediction. So we're predicting ionic compound. If the substance is ionic, then when placed in water, and then I'm basing this answer on those properties I've answered above. So do I think an ionic compound will dissolve? Dissolve only if it's polar, or dissolve if it's nonpolar? Well, I'll give you a hint that polar and nonpolar are terms that only refer to covalent bonds, since when we're sharing electrons, that's when we can have that polarity. So again, if the compound is covalent, then when placed in water, and I'm making a prediction here as well. And then we also want to make a prediction about our boiling point based on what we know about ionic versus covalent bonds. So based on what we've put up in our table, I'm going to answer if the compound is ionic, then and I'm going to make a prediction. Will it remain a solid, never boil, have a high boiling point, or have a lower boiling point? Similarly, I'm answering for covalent here. Then I'm just going through and I'm figuring out what are my independent and dependent and controlled variables. Remember, my independent variable is what I'm changing, and then my dependent variable is what depends on that. So I'm filling these in. I'm saying which one is my thing that I'm experimenting with, and then what do I expect to change as a consequence of that? That'd be dependent. And then the things that I'm going to keep the same no matter which variable I'm using are going to be my controlled variables. So my procedure, first we test how much of each compound dissolves. And now I have my prediction that I've made in the back of my head as I go through this. It says we should use the same amount of water and solute for each test. Oh, those sound like controlled variables. I measure out 100 milliliters of water into 2 beakers and I label them A and B. We should also have a control group. I fill beaker C up with just 100 milliliters of plain water. Then I measure 50 grams of each unknown compound. Add compound A to beaker A and stir for 1 minute, and compound B to beaker B and stir for 1 minute. Stir the control beaker for 1 minute as well. So now I have my 2 unknown substances in my 2 glasses, and I can do the experiments to figure out which one is dissolving more quickly. Okay, so now I'm going to get into the actual trials of the experiment, and then we'll draw our analysis and our conclusion, and we'll talk about how to do each of those. So I'm going to do my data collection, my analysis, and my conclusion now. So first I did trial 1, and it says ability to dissolve. So that's what I'm testing in my first table here. So it says after 1 minute, there is 0 grams of compound A left undissolved. There's about 15 grams of compound B left undissolved. Control group C has not changed. Record this data on your lab worksheet in table 1. So that's what I'm filling in here. It said compound A at the end of my experiment had 0 grams left. and compound B had about 15 grams left, and compound C, which is just plain water with none of either mystery substance in it, did not change. So that's all I need for my data collection for table 1. Then we will test the boiling point of each solution. Each one is currently at room temperature, 23 degrees Celsius. Place each beaker onto a hot plate. When the solution boils, use a thermometer to record the temperature. So that's what we did. We said, okay, now we're imagining we're putting our our 3 solutions on a hot plate, and we're taking the temperature when each one boils. We know one contains salt, we know one contains sugar, and we know one just contains water. So we go in, we do this, and the temperatures we record are as follows. Solution A, which contains one of the mystery substances, has boiled at 102.8 degrees Celsius. Solution B boils at 108.7. And then solution C, which we know is just water, boiled at 100 degrees Celsius. So I know both of the substrates that I put into my water solution caused the boiling point to go up, but one caused it to go up a little bit more, and that's going to be solution B. So I'm filling these numbers into my data table. So solution A with substance A went up to 102.8 before it boiled. The other one went up to 108.7 before boiling. And then solution C just hit the boiling point of water at 100. So I'm just filling those in here from my data descriptions. And now I'm trying to draw my conclusions. So I'm thinking back to my objective. What was I trying to do here? I'm trying to use the information of these results to figure out which solution is salt and which solution is sugar. I know salt is an ionic compound, and I know what the properties of ionic compounds are based on what I filled in this top table. So I'm matching up what happened with what the known properties are, and I'm saying which of these matches an ion. That's going to be the one that's salt. Which of these matches a covalent compound? That's going to be the one that I think is sugar. So first it asks which compound dissolved more easily. So I'm looking back and I'm saying, okay, well, solution A dissolved completely, all 50 grams. Solution B, most of it dissolved, but some was left over. So I'm going to say solution A, or compound A, dissolved more easily, since there was still some compound B left over. Which had the higher boiling point? Here I'm going to my solutions and I'm saying, okay, well, A went up to 102.8. Compound B brought the boiling point up to 108.7. So compound B had the higher boiling point. And then I'm trying to remember, wait, what does boiling point have to do with my bonds here? I have to think back. I may need to go back into my reading here about my properties of my compounds and see if I can find why the boiling point is related to those things. And that's what I'm going to answer in here. What does the boiling point have to do with the strength of the bonds? And then finally, for my last 2 questions, this is where I'm drawing my conclusion. I should say which compound is A and which compound is B, and I want to state all of the evidence that supports that. So for each of these, I should have something that looks like this. I should be saying either compound A or compound B. You're not going to write A/B. You're going to pick one, either A or you're going to pick B. This one's asking me about the salt. So I'm picking, which one do you think it is? Is it A or is it B? That's what you're filling in here. That you're going to pick one of those. And then you're going to say, the reason I think this is because, and this is where I want you to cite data from both of the tables. So I want you to put something here. So here you'll cite data about solubility, how much of it dissolved in water. Oops. And I know that ionic compounds. So you're going to explain why does that mean it's an ion? So here, I'm citing my data. And then here I'm connecting it back to what I'm claiming. I'm saying, okay, and because this is what my data showed about solubility, that means it has to be an ionic compound. So that means it has to be the salt. And then very similarly, we're going to do the same thing now, but we're going to cite our other data. So we're going to say and, oops. Oh, that's annoying. And then we're going to cite data from our lab about the boiling point. And then we're also still going to do the same thing. We're going to connect. Okay, wait, why does that mean that it has to be salt? So I'm citing data about my boiling point, and I'm saying, and I know that ionic compounds, and then I'm going to explain what does this have to do with the boiling point. How do I know that that means that it's an ionic compound? So here, explain boiling point of ionic compounds. And then here, you'll explain solubility of ionic compounds. So this is really the heart of, did you understand what you were doing in the lab, and were you able to determine what was going on? Down here, it'll be almost the same, except you're going to do the same but for sugar. So you're going to cite data about the solubility, and you're going to talk about covalent compounds for these, because you know sugar is a covalent compound. So this will be covalent, and this will be covalent. So very similar, but here you're talking about covalent. So these are where I'm seeing a lot of students weren't sure what to do. This is really your conclusion. So you're thinking back to, what was I trying to do in this lab, and how can I explain all of that? So hopefully that's helpful. Please reach out if you need any more support as you're going through this lab activity.